Welcome to first tutorial session with WateraiStudio. Well, landing with this tutorial is to create new project. Click on plus sign to create new project and name it properly, then click on create. Assign the file location on your local drive. First thing is that your project is loaded with world map that come to window, where now you can zoom and navigate your area of interest. In our case, let's zoom to Jordan country and navigate the north area. Here you can add your nodes and map features you're going to simulate. Right-click context menu on map can show you nodes and features to add according each type. Also, you can draw rivers from toolbar. Then you might find Saving Project under Actions menu. Also, you may find Close Project. This will give you dialog to confirm save changes. Now, loading the project again in same menu, and then open project by browsing local drive, and then choose the project and open. Well, first thing to do for your first project is to assign the base year you're going to define and how many simulation years of project you are using. Then, you must assign the time granularity from menu according your data and time steps. We choose now monthly time steps for the year 2020. Now, first thing to do is to start your model by creating catchment node, which is the first hydrological step to do. Name the catchment and then put its coverage area by squared kilometer unit. Now, after that, for easiest data input, you can click on Fetch Geodata button, where many data about this catchment will be imported into your model. These data is about rainfall, evapotranspiration, and other hydrological parameters. Now, for catchment runoff method, we choose curve number as average value for the catchment settings. After that, assigning the recharge factor as coefficient from hydrological process of catchment, and we can directly assign 5% as goes to recharge. Save changes, and continue building your model. After creating catchment node, we need to draw a river as the next thing to do. Select Draw River from icon and click on Map for the start point and end point of the river. And then click Finish River from toolbar. Right-click on River Segment to add River Segment node at the start of river and name it like Head Flow node. Now the node is added. The next step is to link this node with catchment. Right-click on catchment and connect to Head Flow node. You can also add reservoir dam on the river. Right-click on River and add reservoir. Name the reservoir properly from right side property panel. Reservoir node has another properties which we can navigate later, such as max storage and initial conditions. The reservoir may simulated later for losses by evaporation and other parameters. Also, in same river, you may add another river segment node called river outlet for our purpose. So, you name the outlet node, and then your river now is ready created. Now, the water model system we created till now includes catchment and surface runoff features and data. The next step of our simulation is to add aquifer to this water model. You need now to connect the catchment with aquifer created. Then add wells feature to the map, which will be integrated with aquifer for withdrawal conditions and wells pumping. If you need, change its name and connect the aquifer with wells. Save changes every time. Now, to link the wells pumping service, you must create demand node. This would be domestic demand node from context menu. Let's connect wells with domestic demand. Now, let's fill some data for our model. Assign the production capacity for wells node, which in turn would be the monthly threshold of pumping. Set it like 1 million cubic meter by each month as wells production capacity. Wells node also has capital cost as infrastructure. Domestic node now must be filled by another data. First is the population of this demand. Assign it like a number of population around the year 2020. You can choose Smart Fill way to add the population every month. This way, the data of population method you choose is assigned in all months. Then, go to define below the per capita water use rate as liter per capita per day as monthly basis. Another thing to do is to assign the normalization of this water use as 1:1 every month, which you may change later as summer factor is above 1. Add economics and capital cost for infrastructure capital. Another thing to do, additionally, the returns will be calculated in the model by assigning the tariff system below. Add 2 tariff steps and define cost for each meter cubic water pricing. I can say now that simply with smooth steps we done till now your model is created and you can run the simulation. Now back to your model. After saving, you can visualize the behavior of the water system by playback controls, and every month visually the model will show you the behavior of water demands and supply. Thanks for watching this important tutorial.